Good evening, everybody. My name is Walter Poindexter, and you might have heard me doing some other stuff in the Arboretum tonight, and I'm one of the scientists who was kind of working on that. So, yeah, that's why I'm talking to you now. Well, there was something that I was talking to with Dirk earlier there in the lab about what science actually is, and I wanted to just cover that a little bit more for you right now. Because sometimes when we think about science, we're thinking about stuff that isn't actually science. I mean, it might kind of look like science, or it might be something that we really strongly believe, but is it really science? Well, this is how you can tell, okay? So, when we do science, what we're trying to do is we're trying to describe the physical universe. There are certain things that science can do and that science can't do. If it doesn't have anything to do with the physical universe, or, I can't really tell you about, say, love or anything like that, because that's an abstract. I gotta talk about the stuff that is physical, it's gotta be measurable, and it's gotta be independently verifiable. So, those are three things that science needs to have. Now, let's go over them one by one. Science only talks about the physical stuff. The physical stuff can be objective. That means that ideally, anybody can encounter it and experience it in the same way. It doesn't mean that we always experience it in the same way, but it means that it's possible. In science, we can't really talk about things that aren't physical. We can't really talk about your imagination unless we're talking about, say, the nerves and the electrical impulses in the nerves. Can't really talk so much about the thoughts that you're talking about, or at least we have limits to that. Now, science also has to be something that is measurable. It's really great that we have measurable evidence because that helps us to quantify things and convert it into numbers, and when we get it into numbers, then we can start to use mathematics to simulate things or model them or communicate them to others in a really precise way. Perhaps most importantly, scientific evidence has to be something that is independently verifiable. It means that, ideally speaking, anybody should be able to do the same sort of experiment and get the same kinds of results. Now, obviously, there are some practical limitations to that. I mean, it's not like everybody can build a Hadron Collider in their backyard or something like that. It just isn't gonna work. Plus, it does take a lot of work to try and learn how to do some of the more technical aspects of it. It takes a lot of training, but theoretically, you should be able to get anybody who's interested in investing the work capable of doing that. If somebody reports on something like, say, a ghost or sometimes alien sorts of things, something that they could see, but then nobody else can, go and check up on it, then it's not something that science can really examine for good or for bad, or to confirm it or to disprove it. It's just something that science can't really say much of anything about. Now, you'll get differences in how people think that we might be able to use the physical universe and just exactly what counts. So it's not like there's a universal standard because, we're studying the universe. It's a really complex place, and if you're going to make a universal standard, then it's got to be something that is accounting for things that we haven't studied yet. That doesn't really make sense, does it? Other things that science doesn't really cover would be the possibilities. Sometimes you'll hear people say, science is wonderful because that allows us to explore the possibilities. And, well, that's kind of true, but it's not what science is all about, because what we're really trying to do is disprove the possibilities. We want to destroy the possibilities so that we understand what's actual, not just possible. So, yes, we do explore the possibilities, But what we're really trying to do is just figure out how things actually work. Along the way, then we end up working with inventors and engineers, and sometimes even, say, science fiction authors. Those fields are much better about exploring the possibilities and taking the findings of science and doing something with them. So it's really important to keep that in mind. As scientists, we're explorers. We're constantly learning things. That makes science more of a journey than a final authority on everything. Yes, we deal in facts, but not every scientific idea is going to be a fact. We've got hypotheses, we've got taxa, we've got scientific models, and a whole lot of other kinds of ideas that aren't facts, but they help us to figure out what is fact and what's not. So it's a little bit more complex than sometimes people think, but it's still a very important way of understanding the universe. So hopefully that helps to kind of clarify some things and give you some jumping off point for exploring science further. It's really great stuff.